Hello friends, so today's question: a block of mass 10 kg is kept on a rough floor. The coefficient of friction between the floor and the block are static is 0.4 and kinetic is 0.3. Forces F1 5 Newton and F2 4 Newton are applied on the block as shown in the figure. Find the magnitude of frictional force. And B, if F1 is 5 and F2 is 8 Newton, for what maximum value of A the motion of the block impends. So this is the block, two forces which are being applied to it. So we are supposed to find out what will be the frictional force. First of all, let's find out what will be the net force which will be acting because of this F1 and F2. So we can resolve this. So this will be F2 and we have F1. So the net force which will be acting will be somewhere here. Let us call this F net. We can write the equation as F net, which is net force on the block this will be equal to F1 square plus F2 square and its square root. We substitute the value, it is given as 5 and 4, so we can say that our F net will be equal to 4 square plus 5 square square root. So this will be 16 plus 25. So we get our F net is equal to, this will be our 41 square root newtons. And now let's find out what will be the maximum value of the friction that will be acting. So in the downward direction we are going to have mg, and in the upward direction we are going to have a normal n. Okay. And from here we can say that the normal will be equal to mg, and if Fr is the force of friction, then the maximum value of the friction Fr, you can say maximum value of the friction Fr max is equal to mu into n, and it is 0.4 multiplied by mass is given 10, g is also 10, so we get our Fr max as 40 Newton. So if you make a comparison between the net value of the force and the maximum value of force, so from which we can say that our Fr max is greater than F net. So because of that, the block will not move. The block will not move. Therefore, the magnitude of frictional force will be equal to F net. Fr will be equal to F net, and that is equal to square root of 41 Newton. This is our first part. In the second part, we are supposed to find out what will be the maximum value of A the motion of block impends. So part B, so in part B, we already know that the maximum value of the friction is our 40 Newton. Fr max is 40 Newton, and now we have two forces, F1 is 5 and F2 is A. So you can say net force F net is equal to square root of F1 square plus F2 square. Substitute the value, we get 5 square plus A square. So F net will be equal to 25 plus A square. Now it says that the motion of the block impends. Okay. So we can write for the motion of the block to impend, Fr max should be equal to F net. Fr max should be equal to F net. We can say that 25 plus A square, its square root should be equal to 40. We can say 25 plus A square should be equal to 1600. If you solve it, we get A is equal to 1575 square root meter per second square. Okay, so this is the final answer. Thank you.